So let us talk about binomial distribution today. See, there are many experiments whose outcome is going to involve either of the two events. For example, there is you toss a coin, you get either head or tail. So a child is born, can be male or she can be female. So the two events, right? So you can put the probability of success as P and the probability of failure as Q. Now note that when I say that you are saying that coming of head is a success, that is some goodness attached to it. No. We are just interested in finding out the probability of success. So we are defining something as a success. So there is no goodness attached to it. Now, let me tell you about the Bernoulli trial before I tell you about the binomial distribution so that we can connect it. We can connect binomial distribution with the Bernoulli one. Well, as far as Bernoulli distribution is concerned, so the trial is the repetition of an experiment in which there can be only two outcomes, right? So for example, you toss a coin, you roll a die, and you are interested in finding out the probability that the die is coming up, or the number which is being shown up is 6 or not, or whether you will win a match or not, whether you will pass an exam or not, right? So that is what is meant by Bernoulli trial, right? So it is a trial in which each repetition is going to result in only one of the two outcomes, right? And you write Bernoulli trial as like this, Bernoulli distribution as this. That is Bernoulli P, where P is the probability of an event to occur. So maybe you are interested in finding out what is the probability of passing this exam. So that P is this here. Or you roll a die. You're interested in finding out what is the probability of getting 6. So that P is what is this here, right? Now we are going to connect this with the binomial distribution. So what is a binomial distribution? The binomial distribution would be the collection of Bernoulli trials for the same event. Collection of trials, more than one Bernoulli trials. And one trial is not affecting the outcome of the other. One trial is independent of the other, right? Also, they are repeated, right? And the conditions in which they are going to be repeated, they're going to remain same. So for example, you toss a coin, whether you will get head on the first toss is not going to affect the probability of getting head or tail in the second toss, right? Repeated. What do you mean by repeated? So repeated is that the conditions in which you are experimenting, that those are going to remain same. So hopefully you have taken up the unbiased coin. So in the next trial, again, you're going to take up the unbiased coin. So biased coin would be one which can increase the probability of getting, let's say, head. So binomial distribution is the collection of the Bernoulli trials for the same event. So it contains more than one Bernoulli event for the same scenario under which the Bernoulli trial is calculated. So we are often interested in finding out the outcomes or the probability of more than one or the repeated independent Bernoulli trial, right? I've told you about independent. The outcome of one trial is not going to affect the outcome of the other. Repeated, the conditions under which the trial is going to be taken up, that those conditions are going to remain. So that is what I've said. So we are interested in the result of the independent repeated Bernoulli trials. I've told you the meaning of independent and I've told you the meaning of repeated, right? So when you write for the binomial distribution, you write, how many times this experiment is repeated and what is the probability of success, right? There in Bernoulli, it is repeated once, right? Here it is the, I mean, in case of binomial, it is the collection of Bernoulli trials for the same event. So that is what the difference of Bernoulli and binomial. So Bernoulli is that you are dealing with the outcome of the single trial of an event. Binomial is that you are dealing with the outcome of the multiple trials of that single event. That is the main difference between Bernoulli and binomial. So in Bernoulli, we might be interested in finding out what is the probability of getting head in a single toss. While in binomial, we might be interested in finding out what is the probability of getting 4 heads in 10 tosses of a coin, like that, right? So that is what an example of binomial distribution, that how do we calculate for the binomial distribution. Let's have a look at it. So here we are interested in finding out the probability of getting 4 heads in 10 coin tosses. The first thing is that we are going to determine what is the probability of one possible way that this event can occur. And then we are going to determine the number of different ways in which this event can occur, right? That is what we are interested. So the probability of event is basically the number of ways an event can occur into the probability of one occurrence. Into the probability of one occurrence. So in this case, the number of times is the trial is going to be taken up is 10, and you are interested in finding out the probability of getting 4 heads in 10 tosses of a coin, 10 tosses of a coin, right? So the number of successes R is equal to 4, and the number of failures in which this is not going to occur is 6. So in the 10 tosses of a coin, 4 times head should come up, 6 times tail should come up. This is the way. So one of the way in which this can occur is what? Let's say you get head on first, head on second, head on third, head on fourth, and then tail, 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 and tail. You can get this. No. So you can also write this as, this is what we call as success, and getting tail is what we call as failure. And getting tail is what we call as failure, right? So more generally, your P is the probability of success, Q is the probability of failure. So getting head, your P, this is the probability of success. That is, you are getting head, and Q is the probability of failure. And this is coming 6 times, your N minus R, or you should rather write 6 out here. Or I can also write it like this, P to the power R, Q to the power N minus R, Q to the power N minus R. So the probability of getting a head in a single toss is half. Probability of getting tail in a single toss is half. So you can just put it. And this is going to come out to be something like 0.00097, something of this thing. But just imagine this. I mean, this is just one way of getting 4 heads in the 10 toss, in the 10 tosses of a coin. It could have also been like this. You're getting 2 heads initially, then you're getting 6 tails, and then you're getting 2 heads again, right? Then you are getting 2 heads again, right? So this is just one way of getting it. But then how many ways it can occur? That is what we're interested in. So there are 2 counting rules here. What are these counting rules? So the 2 counting rules here are the number of different ways that the n distinct things may be arranged in the order is n factorial, right? And the number of ways of selecting r distinct combinations of n objects irrespective of the order is NCR. So what is p to the power r, q to the power n minus r is telling you? Right, let me write it here. P to the power r, q to the power n minus r is telling you. This is actually telling you the probability of each individual sequence. Probability of each individual sequence, right? And what is NCR is telling you? It is telling you the number of sequences that are going to produce R successes in N trials. Number of sequences that will produce R successes in N trials, right? So the probability of, when the probability of success is equal to P, and the probability of finding out exactly R successes in N trials, so that is going to be NCR P to the power R Q to the power N minus R, right? That is what we want to write this thing as, right? And this is what I can call, this is what your binomial, the way I'm going to solve the binomial distribution, right? So any random variable X. So let me just write one more point. Any random variable X with a probability function with a probability function given by like this, NCR P to the power R Q to the power N minus R is said to have binomial distribution with parameters N and P, right? So in our case, your NCR, your NC4, when you'll do this, this will come out to be 210. And the probability that you'll be getting 4 heads in 10 tosses is going to be 210 into 0.00097, right? 0.00097. So this is approximately 0.205, something like that. So this is what the binomial distribution is. This is what the binomial distribution is. And let us also just write, for the sake of completeness, the mean and the variance of the binomial distribution. Mean of binomial distribution. But before than that, I must recall what is the mean of Bernoulli distribution, right? So if you remember, you can write your Bernoulli distributions distribution probability density function as this. So if x is equal to 1, that is a success. If x is 0, that is a failure. If x is right. So for any discrete random variable, E of x is nothing but summation of x into px. So exi would be what? It is summation of xi into the probability p plus summation of xi, which is 0, into the probability 1 minus p. So that is coming out to be equal to p. So mean for the Bernoulli trial is p. But you also know that your ex is so if there are n Bernoulli trials and you take up the expectation of all of them, so this is going to come out to be like this. And ex1 is also p, as we have shown you. Exi is p, so ex1 is p, ex2 is p, and so on to exn is p, right? So this is done for n times np. So binomial is nothing but Bernoulli trials repeated n times. That is one thing. The variance of binomial distribution. So how do we write this? Beta, in Bernoulli trial, x can take up only two values, either 0 or 1. So x, when xi is 0, xi square is also 0. When xi is 1, xi square is also 1, right? So I'm just finding out the Bernoulli trial variance first. So for any Bernoulli trial, xi star is equal to xi. Now, because xi can take up only two values, 0 and 1. So xi is 0, that is xi square is also 0. Xi 1, xi square is also 1. Okay. So variance of xi is what? E of xi square minus E of xi ka whole square, like this. So whether you write E of xi or you write E of xi square, that means one and the same thing. And E of xi, you have just said it is equal to P. And this is P square. So you can take a P common. This is 1 minus P. This is nothing but equal to PQ. Now, binomial distribution is nothing but the, repeated Bernoulli trials, independent repeated Bernoulli trials. So variance of x for binomial distribution. It would be the variance of n independent repeated Bernoulli trials. That is variance of x1 plus variance of x2 and so on to variance of xn. So this is what? PQ plus PQ and so on to PQ. This is nothing but NPQ, right? So that is the variance of binomial distribution. So what is it that we have done in this class? We have defined what binomial distribution is. We have defined what Bernoulli distribution is. We have found out the difference between the binomial and Bernoulli. We have found out how we can calculate the probability of success for the binomial distribution. And we have also calculated the mean and variance of Bernoulli and binomial distribution, right? Thank you, Beta.